Advanced Algebra, Chapter 7, Lesson 2, and we want to look at dividing radical expressions. Now there's one thing I want you to remember as we're moving forward, and that is everything that we've learned so far we have to continue to do even though we're looking at dividing or adding or subtracting, meaning we always want to simplify our final answer as much as we can. So what we learned in lesson 1 about simplifying radicals, taking the cube roots or fourth roots of numerical radicands, or taking the cube root, fourth root, fifth root, whatever, of variable radicands, we want to continue to do that so that our final answer is always simplified. Some of the things that we can do as far as simplifying first that I talked about in the other video, simplifying before you multiply, we want to continue to do that in this video as well. We want to simplify radicals before we divide them. In some cases that's going to help us, and sometimes it's a mixture. Sometimes you'll simplify some first, then do the division, and then have to simplify afterwards, or maybe divide first and then simplify afterwards. So there's a lot of different ways to do this, in that the order that you do some of them doesn't matter in most cases, but we have to remember that our final answer has to be in its simplified, most simplified version. So we need to remember what we've done and continue to always think about doing those moving forward. So I don't know if that sounds right, but let me try to sum it up with them really quickly. Simplify all your answers all the way. If it's not simplified, if there's more that can be done, then it's not going to be correct. So we have to make sure that we're always looking to simplify every step of the way. Dividing radicals, really a couple of the same rules that we had when we're multiplying. The indexes must be the same. You cannot divide a square root by a cube root. There's nothing more that you could do with it other than simplify those square roots or simplify the cube root. But as far as doing something with the radicand under a square root and the radicand of a cube root, there's nothing that you can do. The indexes must be the same. So that rule still apply. Now division really is just like simplifying a fraction. If we have 12 over 3, that really means 12 divided by 3. But we don't have to go out and do our long division algorithm. We simply reduce the fraction, and that is doing the division. So if I divide both of these by the common factor of 3, I have 4 over 1, which is 4. 12 divided by 3 is 4. So really the division algorithm is simply can be replaced by doing some reducing of a fraction. Dividing radicals is the same way. It's a fraction, and so we're going to simplify it, keeping in mind that we can only divide radicals with the same index, and we can only work with radicands that go with radicands and non-radicands working with non-radicands. Non-radicands being those values that are outside of the radical symbol. So radicals with non-radicands, multiplying and dividing have to be the same degree. And work with the radicands and the non-radicands with non-radicands. But we never mix the two. We can never mix radicands with non-radicands. So for example here, the cube root of 32 divided by the cube root of -4, the indexes are the same. So what I could do is put them underneath the one radical sign, and then I have a fraction underneath there, and apply what I know about reducing fractions. Both of these are divisible by 4, so I would divide by 4, and now here's what I was talking about. You have to continue now to simplify your answer. The cube root of -8 can be simplified further. That goes back to what we learned in lesson 1, so I'd want to simplify that to -2. Let's take a look at this one. We have some variables involved and some numerical radicands involved. And so the indexes are the same, so I can put them underneath 1 and then go ahead and reduce. Now, the 3 and the 62 are both divisible by 3, so that ends up being 54. Now, when we're reducing variables, one way to look at it, what I like to look at, well, x to the 5th divided by x squared means I have 5 x's in the numerator and I have 2 x's in the denominator. So I can take 2 of these and reduce them with 2 of these, leaving me only 3. So this is x cubed. So whatever way the mathematical definition or mathematical operation is when you're dividing the same bases, the exponents are subtracted. I kind of think of them as having this many exponents in the numerator or this many in the denominator, and so I reduce them that way. So the x squared, that's 2 of them. I take away 2 in here, that's leaving me x cubed. So now I have the cube root of 54x cubed. Now I have to go back and remember what I did before. I have to simplify this. I'm not done just because I reduced the fraction. I have to simplify my answer. So I'm going to do the cube root of 54. So again, I can do my prime factorization. 2 divided by our end of 54 is 27. I recognize that the 27, the cube root is 3, so this ends up being 3. And then I have the cube root of 2, and then I have the cube root of x cubed, which is 3x, or which is x. So then the simplified version would be 3x cubed cube root of 2 as my final answer. Okay, so don't forget, after you've simplified, when you get here, you're not quite done. You do have to simplify then this radical according to the properties that we learned in the previous lesson. So let's do number 24 here. I have the square root of 48 x cubed and the square root of 3xy squared. Because the indexes are the same, I can go ahead and simplify this. So I can reduce the 3 and the 48, that's going to be 16 up here then. I can take 1x down here, and there's 3 up here, and take away 1, so that leaves me 2x's up here, and then I have still the y squared down here. So I've done all the dividing or the simplifying, so now I need to simplify each one of these radicals. So the square root of 16 is 4, and the square root of x squared is x, and the square root of y squared is y, so my final answer would be 4x over y. Alright, so for number 25 here, I have, let's see, the square root of 56x to the 5th, y to the 5th, over the square root of 7xy. The indexes are the same, so I'm going to go ahead and reduce what I can. 7 into 56. Well, 7 times 8 is 56, so that can reduce with that, leaving that an 8. So I have the square root of 8 up here. I have 1x here and 5x's here, so I take away 1 here, that leaves me 4. And then I have 1y here, and I take away 1y here, so that leaves me y to the 4th. So all of this has been reduced to the square root of 1 then. And the square root of 1 is just 1, and this over 1 ends up being just this. So I have done all the simplifying, so that is finished there. Now I want to simplify this square root. The square root of 8 is 2 square root of 2, and then because the index is 2, 2 goes into x to the 4th twice, so I have x squared, and 2 goes into y to the 4th twice, so I have 2x squared y squared square root of 2 as my final answer. Okay. In number 26, I have the cube root of 250 x to the 7th y cubed over the cube root of 2x squared y. So because the indexes are the same, I can reduce. So 2 goes into 250 125 times. I have 2 x's down here and 7, so I reduce 2 of these with 2 of those, leaving me 5. And I reduce 1 of these with 1 of these, leaving me 2. So all of these reduce down to 1, so I'm left with the cube root then of 125 x to the 5th y squared. So now I'll simplify this according to my rules. All right. Well, the cube root of 125 is 5. 5 times 5 times 5. 3 into this 5 goes 1 time with a 2 left over, and 3 does not go into the 2 here, so both of those stay underneath. So my final answer would be 5x cube root x squared y squared as the division problem, and then simplify. So 5x cube root x squared y squared. Okay, so again, combines everything together. Make sure you always simplify your radicals if you can first. That's the dividing process, and then make sure you simplify your answer into its most simple form.